everybody. Today we're going to be covering section 8.11, which is on sewage treatment. The learning objective for today is that you can describe the best practices in sewage treatment. Some of the essential knowledge that we're going to learn about is primary treatment, secondary treatment, tertiary treatment, and basically all the different steps in these phases of how to treat our sewage. So we're first going to start with the 4 steps for this water treatment process. And the first step is going to be primary treatment. This is going to be just like physical removal of large debris, such as like toilet paper, leaves, if we have a stormwater sewer combo system, plastic, sediment, things that have been flushed down. And so this is just kind of removing using a screen or a grate that's going to catch all this stuff. The secondary treatment is going to be the biological breakdown of organic matter, the feces, by bacteria. And then this is an aerobic process that requires oxygen. So as I'll show you in a couple slides, this usually involves some sort of like bubbling mechanism to make sure that the bacteria that are in this phase of the treatment are going to be having access to oxygen so that they can be doing that breakdown. Then we have tertiary treatment, which does not happen in all facilities because it's expensive. But for those that do have tertiary treatment, this is going to be a chemical treatment to reduce the pollutant levels of like nitrate, phosphate, and ammonia. Because remember that this water is eventually going to be discharged into like the ocean or lakes or stuff like that. And when we have higher phosphate or nitrate levels, then that's going to be contributing to eutrophication and an imbalance in like nutrient levels and all of that. So for the systems that do have this tertiary treatment, that's going to be beneficial. But again, it's expensive, so not a lot of places do have it. And then this 4th step is going to be disinfectant. So some places just skip tertiary and go straight to disinfectant. And this is where we have like a UV light or chlorine or ozone or something that kills bacteria or other pathogens such as like E. coli that would be in this water. Now there is a vocab term that you need to know. It's effluent. It is not the same as affluent, which means like wealthiness. Effluent. And effluent is going to be the liquid waste, the sewage that is discharged into surface bodies of water that comes from the wastewater treatment plant. So after it's been treated and it is then released into a surface body of water, that water is called the effluent. All right, so this whole thing here, up at the top here, as you're taking notes, I would just do it like primary treatment and these couple bullet points, and then secondary treatment and these couple bullet points, and then this information on the bottom there. So primary treatment, as we're seeing on the left-hand side of this diagram, this is where we start with those screens or grates that are going to filter out large solids like toilet paper, plastic, stuff like that. Then it goes into a grit chamber that has like gravel and sand that allows sediment, that allows the sand and the gravel to be removed and to settle out. For our secondary treatment over here, this is where we have this big aeration tank where oxygen is bubbled in so that the bacteria can have access to that oxygen so that it can break down the organic matter into carbon dioxide. And then we end up with those nutrients like the phosphorus and the nitrogen. Now we also have the secondary treatment whole process here. So by the end of it, one of the things to be aware of is that it only removes about 70 to 50%, 70% of phosphorus and 50% of nitrogen. And so we are still going to have elevated levels of phosphorus and nitrogen being released with the effluent, assuming they don't have that tertiary treatment. But one thing that's important to note is that it does not remove persistent organic pollutants. We don't really have a way to remove that yet with our water treatment systems. So things like medications or pesticides, that's going to continue going through this system. So if it was flushed down the drain, if it was excreted by the people, you're going to have those medicines in the water. Now, by the end of this, we have what's known as sludge. And sludge is going to be inorganic solid waste that collects at the bottom of tanks in the primary and secondary treatment. Now, water is like spun or pumped off to concentrate it even further. And by the end, you end up with this like dry, physical waste, and it's collected to be put in landfills, burned, or sometimes it can be turned into fertilizer pellets because it has higher levels of the like nitrogen and phosphorus in it. But overall, it is inorganic. Now, after primary and secondary treatment, some plants go directly to the disinfectant step where we have the UV, ozone, and chlorine and discharge it into surface water. But some of the like more wealthier ones that do have the tertiary treatment, they're going to have the tertiary treatment and then the disinfectant so that they can have more of those nutrients removed before discharging it. So I'm going to talk a little bit more about the tertiary treatment that, remember, not everybody has. But the tertiary treatment is going to use chemical filters, which you can see in the middle of the diagram here. These chemical filters are going to remove more of the nitrates and the phosphates from the secondary treatment discharge. Now, this is a really important step because the effluent that is discharged, if it has high nitrate or phosphate levels, this is going to lead to eutrophication. So ideally, you're going to be able to have chemicals in here that are going to bind with the nitrates and the phosphates, which is going to cause it to kind of like fall out. It can be filtered, and then the water is going to have not those high levels in it anymore before it's discharged. Now, remember though, this is very expensive. It is not required, and so many facilities do not use this. But the ones that do, it is good to help prevent eutrophication and those oxygen dead zones and some of the things that we talked about with our eutrophication notes. Now, we do have some sewage treatment issues. Oh, sorry about my photo here. And with the sewage treatment issues, what we are going to be seeing is that we can have these systems where we have a combo sewage and stormwater runoff system. Now, for the places that have those, it's awesome because you actually end up treating your stormwater as well, which does not happen in a lot of places. Usually stormwater just runs straight off into the sound. But if you can have a system where you're also treating it, then again, the water going off into your surface waters is going to be a lot better. So for these combo systems, they're beneficial because you're going to be treating stormwater runoff. However, when you get heavy rains, this causes overflow, which you can see a picture of here, which is like yuck water. What ends up happening with this, and this did actually happen in Seattle a few years ago, the flooding releases raw sewage into surface waters because it overflows and the system gets overloaded. And so raw sewage is then going to be contaminating. In Seattle, it got released directly into the Sound. This lovely picture here, it's getting released into like some local parks, which have local streams and waterways and stuff. And with this raw sewage, you're going to be getting E. coli, ammonia, nitrates, phosphates, endocrine disruptors, and all of that is just like directly going straight into those water systems. Now, even if this like worst case scenario doesn't happen, even treated wastewater is going to have higher nitrogen and nitrate and phosphate levels and endocrine disruptors, because again, we can't get rid of the endocrine disruptors. And so what's going to happen is that is going to still be released. So just keep in mind, even when we have great systems, there's still going to be some of these persistent organic pollutants or these elevated levels in what's going off into these surface waters. Now, here's an important piece of legislation. You may remember from Unit 7, the Clean Air Act. Well, what also exists is the Clean Water Act. And this is one of those pieces of legislation that you need to know for AP Environmental Science. It will probably show up on the test. And this is a piece of legislation that regulates the water pollution to ensure certain qualities for surface waters like lakes, oceans, rivers, and wetlands. So the Clean Water Act doesn't just like remove all of it, but they have like certain thresholds and they make sure that all of the water pollutants are within those thresholds. Now, this Clean Water Act was originally passed in 1971. There have been some updates to it, but that's when it first started. And one of the things that it requires is that different corporations and municipalities and all of that, they need permits for point source pollution. So places where they're going to be directly dumping stuff back in, such as these municipal waste treatments, or even if there's a company that's trying to dump some chemicals from their power plant or whatever it is, they need to have actual permits in order to release these. So this is something that the EPA can regulate, can track. They keep track of all of the like nutrient levels in your local waterways. And so they're able to kind of say like, okay, these levels are really low. So yeah, you can release it here. It'll be fine. Or these levels are too high. You can't release it here. We're not going to approve your permit. And the EPA is in charge of this. And it also gives the EPA power to penalize violators from this. So if there is a company that is just dumping stuff and not getting permits for it, the EPA can come after them. Now, this diagram that I have here actually shows the upward straight line here is when we had the Clean Water Act passed. And you can see all of the decreases in like fecal coliform, which is like bacteria stuff, the number of suspended solids, water that was not swimmable, and all of this has decreased. So our water quality has gotten better with the passage of the Clean Water Act. So just some data there to show that these regulations are good. And this is going to be your practice FRQ for 8.11. I want you to look at this diagram here. Let's see if I can get my face out of the way. There we go. So look at that diagram there, and I want you to identify a number on the wastewater treatment diagram that represents a step of primary treatment. So each of these numbers, we've got 1, 2, 3, 4, 5, 6, all the way through 9 down here. So identify which of these numbers represents a step of primary treatment. Then I want you to describe a pollutant that could be removed by this process. And that is going to be your practice FRQ for 8.11, and those are your notes on 8.11.